Hi, for the last day of our chapter, we're going to take a look at parallel lines inside of triangles that are similar and how the parts end up being proportional. For this one, remember, I am actually going to be gone to the Texas Instruments T-Cubed International Conference, so I will not see you Wednesday, Thursday, or Friday, and your test is on Friday. Just be very careful. I did try to leave this towards the end because out of everything, this is probably one of the easier things, especially since we've been doing proportions all chapter. I didn't want to leave you with the proofs, but I think that this is something that you can do. But don't forget that you can ask your sub for help and each other. And if you still can't figure things out, I do have email. So of course, feel free to send me emails and I will answer them. It's tcasey@lpcsd.org. And again, if you email me, I will get back to you as soon as I possibly can. I really don't want you to feel like I'm leaving you alone, because you can email me and I will get back to you. Okay, so with the last chapter, we learned about a mid-segment. And we said that a mid-segment was when we connect the midpoints of two sides of a triangle. So you have a triangle, you find the midpoint of one side, find the midpoint of the other, connect those midpoints, and you get the mid-segment. And what we learned is that the mid-segment is half of the side that it's parallel to. And that was great. But the mid-segment is not the only segment that can be drawn connecting two sides so that it's parallel to the opposite side, and that's what we're going to look at today. So what we have here, we have B is parallel to D, and A is parallel to E, and what we want to do is figure out if B is the midpoint of AC and if D is the midpoint of CE. So we can easily measure. If we go to measurement, we can measure the length. We can measure from A to B. We can measure from B to C, and very easily we can see that those two are not the same length. Midpoint has to be in the middle, which means that those two segments would be equal, and they're not. So same thing with C to D and D to E. Okay, so those points, B and D, those are not midpoints. So is B the midpoint of AC? No. Is D the midpoint of CE? No. And how do we know? Well, because the lengths are not equal, so it's not in the middle. All right, so next thing we want to do is find values of CB and BA and CD and DE, and are they proportional? So what we're going to do again is measure here. So I'm going to go to menu and measure length again. So I have this segment, and then the one that goes from C to D, and the one that goes from D to E. Now, what I want to do is see if those segments are proportional. So what I'm going to do is insert a math box, okay? And I am going to set up a proportion. MathBox just lets me do math on a notes page. So I want to find the fractions CB and BA. So CB is 2.1 and BA is 3.68. And if I hit enter, it changes it into a decimal, 0.570652. So when I take 2.1 and 3.68 and I divide them, it turns it into a decimal, which is the 0.570652. Now I want to do the exact same thing with sides CD and DE. So again, I'm going to open up a fraction. CD is 2.28 and DE is 3.99. And again, if I hit enter, it turns it into a fraction. So what I'm going to do just really quickly so you can see is I'm going to slide this down so that we can compare those two fractions. Now, let's talk about rounding. What happens down here is that my calculator is set up to round to 2 decimal places. When you round, what happens then is it's going to cause some sort of error. So if we go up here, if we just take a look at the first 2 decimal points, we have 0.57, 0.57. So those two fractions reduce down to the same decimal. If we didn't round down here, these would be exact. But because we rounded, it's going to cause our final answer to be off just slightly. So if we're going to 2 decimal places down here, we know we're going to be accurate to 2 decimal places on the screen. So what we've just shown is that those sides reduce down to the same fraction. What that means is that they are in proportion. So if we go back up here, find the values of CB over BA and CD over DE, we did, and are they proportional? We can say yes, and again, because they reduce to the same number. Now, you can show that they reduce to the same fraction or show that they reduce down to the same decimal. It's whatever makes sense to you. You just have to show that they become the same number. Okay, so if a line is parallel to one side of the triangle, then what that tells us is that it separates the other two sides into proportional parts. And if the parts are proportional, then the lines are parallel. So what we're going to do again is do a couple of problems from your packet so that you can see how all of this goes together. Okay, for the examples from your packet, what I'm going to do are the first two problems on day 5 with you. One is easy and the second one is a little bit harder, but I wanted you to see both. So remember that when you are given that you have two sides of a triangle that are parallel, what that does is it breaks them into proportional parts. So we can say that this side compared to that side, that piece, is equal to this side compared to this piece. So again, if we call the question mark x, that's what we're looking for, our proportion could be x over 28 equals 8 over 16. And then at this point in this chapter, you should be really good at solving proportions. When we multiply in this direction, we get 16x. And when we multiply in the other direction, 28 times 8 gives us 224. Divide both sides by 16, and we end up with 14 is equal to x. Now, take a look at the problem, make sure that that's what you want to find. We want to find this piece right here, so the length of that piece is 14. All right, the second one is a little bit harder. Again, we have two parallel lines, and again, what that does is breaks the sides up into proportional parts. But this time the thing that we're looking for is this whole side right here. So if that's x, then the part of the triangle that goes from this vertex to this point right here is actually going to be x minus 16. Now, when we set up our proportion, along this side we have 15 on the top and 12 on the bottom. So 15 over 12. And on this side of the triangle, we have x minus 16 over 16. And again, what we need to do is cross multiply. So first thing I'm going to do is 15 times 16, which is 240. And then I'm going to multiply the 12 times the whole thing, x minus 16. So 12 times x is 12x. And then 12 times the negative 16 is a negative 192. Now, what I'll do next is go ahead and add the 192 to both sides. So 240 plus 192 gives me 432. And then I can go ahead and divide both sides by 12, and x turns out to be 36. Now, go back to the problem. Make sure that you know what you're looking for. X is this whole length right here, that's 36. And then if you're trying to see if your problem makes sense, if you take 36 and subtract 16, you get 20. So this piece right here is 20, this piece is 16, and the whole thing is 36. Okay, so that should do it for today. Just one little note, when you get to the could do part, don't make it any harder than it has to be. I'm not going to do a whole video on the could do section, but again, basically it's just breaking into equal parts. So for this one, for example, it would be 6 over 12 equals, and then here we have two pieces. So if this one is x, this one is going to be 24 minus x. So 6 over 12 equals 24 minus x over x, and then again cross multiply. Okay, so again, don't make the could do part harder than it is. It's just a nastier looking picture, but it's still a proportion. Okay, and again, if you get stuck on anything, make sure that you email me. I will not be in class on Wednesday, Thursday, Friday because I will be at the Texas Instruments Conference, but I definitely will be checking email, so don't hesitate to email if you get stuck.